All right, so here we have number 7, and I'm going to start by taking each of these that is to the 4th power and representing it as cosecant squared theta squared minus cotangent squared theta squared. Now, the reason that I'm going to do that is because now I can see that I have the difference of two squares. And the difference of two squares is going to factor into the first term plus the second term, and then the first term minus the second term. And we have one plus and one minus, and that's so that our middle terms will add up to 0. Well, once I do that, I'm going to look here at the second parentheses. And if I look at my Pythagorean identity, the third one on the sheet, I can go ahead and subtract cotangent squared theta from both sides, and I get this expression. And so this is actually equal to 1. And so then my first parentheses times 1 is itself, and that's what I was trying to prove. All right, on to number 8. All right, now on this one I'm going to do a few steps at one time. I'm going to change my tangent into sine over cosine, and I'm also going to change my secant into 1 over cosine. All right, so now I'm here. And now I need, look at my operation. I'm adding, and here I'm also adding. So in both cases, I need common denominators. So to get my common denominator, I need to multiply this fraction by cosine over cosine. Leave this one alone. I need to multiply this fraction by cosine over cosine. Leave this other one alone. All right, that is then going to give me cosine x times sine x plus sine x over cosine x in my numerator, and then cosine x plus 1 over cosine x in my denominator. Because remember, your common denominator just stays the same. All right, now I need to go to another sheet of paper. So now from that last page, I'm going to take my sine x and factor out a sine x. At this point, I see that I have my main operation of division, and division means to multiply by the reciprocal. So I'm going to write that out as multiplication. And then I'm going to see that several things can divide out to 1. So my cosines divide out to 1, and my cosine x plus 1 divides out to 1. And so now I'm just left with sine x. All right, last proof that we had was number 9. And it said secant theta sine theta divided by tangent theta plus cotangent theta equals sine squared theta. So again, I'm going to do a few things in one step. So I'm going to use my reciprocal identity to change secant into its reciprocal, 1 over cosine. I'm going to use the tangent identity here to change that into sine over cosine. And I'm going to use the cotangent identity over here to change that into cosine over sine. Now notice, up here in my numerator, I'm multiplying, and down here in my denominator, I'm dividing. No, I am adding. I'm sorry, I got a little distracted because the lights just went out, but we're going to continue here. So in my denominator, that's where I need to get a common denominator. So the first fraction, I'm going to multiply by sine over sine. The second fraction, I'm going to multiply by cosine over cosine. So then I'm going to leave my numerator the same. And I'm going to go ahead and multiply and add my numerators in the bottom. Keep my same denominator. And then again, this is my main fraction bar, which means to divide, which means to multiply by the reciprocal. And then at the same time here, when I go to do this reciprocal, I'm going to do something in the same step. Sine squared theta plus cosine squared theta is equal to 1. So at the same time that I do my reciprocal, I'm going to exchange that for a 1. Then my cosines are going to divide out. Cosine theta divided by cosine theta is 1. And so now I have sine squared theta.